So we're about halfway through this unit. We've finished with the probabilities and counting methods. And what we're going to look at now is probability distributions. Now, probability distribution is really easy to define. It's kind of stuff we've already looked at. We looked at sample spaces with all of the associated probabilities, and that's really what a probability distribution is. You look pretty much anywhere, you'll find these conditions for the definition. You have a set of mutually exclusive outcomes. Each outcome has a probability. The textbooks that I've looked at say a non-negative probability, which I think is crazy because no probabilities are negative that I'm aware of. And the sum of the probabilities for all of the possible outcomes has to add up to 1. Let me show you a real simple example that we've already dealt with. Suppose you flip a coin. You've got 2 possible outcomes, heads or tails. Associated with each of those is a probability of 1/2. They're mutually exclusive, right? You can't have a head-tail. If you have heads, you don't have tails. If you have tails, you don't have heads. There's no overlap. There's a probability associated with each one of those, and if you add the probabilities up, you get 1. That is a probability distribution. And the reason we care about probability distributions is they help us determine the likelihood of events in real-world situations. And real-world situations are all different, so we have many different types of probability distributions that will help us model them. And we're going to be looking really closely at 4 of them in this part of the course, and then another 3 in the next part of the course. We're going to be looking at the ones that are dealing with discrete situations here. Remember, discrete from the first part of the course means where there's gaps between the numbers. So if I'm talking about how many, I flip a coin 10 times, how many tails did I get? Well, I couldn't have gotten 3.5. Had to have been 3 or 4. So situations like that where there's gaps between the numbers, or possibly when you're not even dealing with numbers like heads and tails in that example, that's going to be a discrete probability distribution. I want to do a couple of counter examples first, just so you have an idea what wouldn't be a discrete distribution. Let's suppose you roll a die. And I list the outcomes here as maybe you got a 6. Or maybe the number you rolled was even. Or maybe the number you rolled was less than 3. This would not be a probability distribution because our outcomes here are not mutually exclusive. 6 is an even number, and there are even numbers less than 3 here. So 2 would count both as being even and less than 3. So these are not mutually exclusive. Don't need to erase that. Another example, if I were to look at rolling a die, suppose I've got less than 4, and then 5 and 6. Well, I've got a probability of less than 4 would be, there's 3 numbers less than 4, so that would be 1/2 or 3 out of 6. The probability of rolling a 5 is 1 out of 6. The probability of rolling a 6 is 1 out of 6. If I add those together, I only get 5/6. I left out one of my outcomes there, namely the 4, so my probabilities don't add up to 1 like they should. And that's really the only 2 ways you can fail to have a probability distribution that I care about. Either your outcomes probabilities don't add up to 1, or you've got some overlap in your outcomes there. We're not going to really run into any situations where anything else is an issue. So that's it for probability distributions. Next time we'll look at, well, that's not it. That's it for introducing probability distributions. Next time we'll look at what I'm going to be expecting of you from the 4 different distributions, and then we'll jump into those distributions.